We will be doing Jefferson Project.
I've been a lot of
Yes, yes, you can change it.
That's where it was today.
If you're interested in it,
We're going to be using it.
I would work on it today.
We're doing this, yeah.
Right.
Trying to fix stuff that Wells Fargo is doing.
Oh, and those ones are doing something.
I should say the artist.
Sorry, I didn't tell you.
Cool. I'd love to catch up with you.
Yes.
I'm right.
With me.
It's a pleasant sound.
It's the world's loudest, whatever it is. Actually, I need this. This needs to be me. Actually, I don't need to be connected. That's wrong. Jim just needs to be connected.
Where is he?
McCusker.
I'm not sure I have him in the house.
Okay.
I'm sure I can find him, but forgive me.
They'll just have it.
That means he can find my.
Ah.
Yeah.
There you go. I have a find position name.
Yes, what can I tell you? Oh, that one's been the same for 5 years, but
That's-
it's been a long time since I've seen you.
Yeah.
Yes, when you're ready, bring up your thing so we can see that feed's working. And let me double check the mic. What's that? Yeah, well, we switched to, so you probably heard of Google Hangouts.
Yeah.
So there's a flavor of that called Hangouts on Air.
Okay.
And what they do is a live stream to YouTube. So you see it through YouTube. And the way it works is that it's like a live edit. It's watching whoever's like the driver. So whatever I have as the thing, whatever I'm seeing is what goes to the feed, right? So that's why the camera and the screen, I'll switch back and forth.
Wait, so I have to plug this in?
Yeah, you need to do that. And then
I need the adapter. It's
there's-
upstairs. Oh, yeah.
And if it's not one of those, it's probably in the other one. And then just as soon as we stop broadcasting after an hour, it saves it to YouTube.
Perfect.
Yeah, so it's all.
So then you can replay it anytime.
That's right.
That's
And you can
nice.
also, it goes to the TWed YouTube channel. It's also possible to edit it, although editing a YouTube videos it's not optimal. It's doable, but it's a web-based editor. You're sort of.
Will this do what I want it to?
So whenever you're plausibly ready, I'll get us going. There's nobody in the thing yet, but I don't know.
Oh, Anna's people didn't call in?
I don't
They were going to, okay.
I don't know how they were gonna call in.
Well, I forwarded the email from you.
Well, they'll probably be following on the YouTube channel.
Oh,
Yeah, they don't have to be in the Hangout. They can be on the YouTube. They can be watching the
This
stream.
isn't doing anything.
oh,
So,
okay.
yeah,
So if I just forwarded the announcement that you made, that's enough for
That's
that.
another, okay, that's, what they're seeing, like, if they're watching, they're seeing the test pattern. It'll be in there. It's working for me, so all these should be okay.
Then maybe you can show it.
I can't juggle them. I mean, I could try to juggle them, but it would
I'm
be
checking.
non-ideal. I'm happy to see someone. I get this started just to Jim and stuff. The one with the missing pin.
Oh, well,
It's probably not, because it worked for me. That's good. Okay.
Right.
We also may have another adapter that one.
Oh, that might be this. It doesn't seem to be.
You don't want to take out that cable.
Of course, if you have. Is that the HDMI one?
This is an older one. Why you want to swap it into the projector? Okay. Good. So thank you everybody for being here tonight. It's really awesome. Welcome back to the
Oh, you said a phone was coming. Okay.
she's waiting for it actually to go up and running. She's a smart person. I already said welcome because all of you were here last week, right? John, what are you talking about? Everybody gets my emails, right? Except for Erica probably doesn't. Was anybody not on the Tetherless list?
No.
Yeah.
Can everybody speak? Yes, John.
John, what did you guys do that?
What's that?
Where did you guys do that?
Delmonicals.
New one, right?
It's a new place. You like it better?
It's really better. Okay.
Is it better?
Here to ignore.
Oh, so you're saying the 2 or 3 people who went last week reported back and said there's awesome pizza. So next week we'll hold this in MCAP, right? All right, let's
Almost there.
so while you're doing that, I'll double check my audio, make sure
Right.
the ball is not. You good? It is on. It's just warming up. Okay. All right, let's. People have been patiently waiting.
So we'll go, you're up. Why do I not see the?
There we go.
So I've got you on screen and I'll be able to, and just, I'll see you sharing, but right now it's the video.
Is it sharing it?
Not yet,
Not yet, but I'll introduce you. It takes a couple seconds to propagate.
Well, it's showing me. Wait,
Right, you don't want to actually have your thing up.
I think I need to change this
Yeah.
entire screen share. Okay. Ooh, hello.
No, you need to be showing.
I'm getting there.
Yeah,
Yeah,
that's
that's
perfect.
perfect.
That's perfect. And I see that. That's perfect.
All right, so let me talk. I didn't say this before. Welcome to the second TWed of the spring 2016 term. Those of you who haven't signed up yet, I'm really looking forward to your signups, Hal. Just a couple logistical things. This is being live streamed, so just keep, and it will be recorded, and it will be available after, so just keep that in mind when they comments, questions, whatever. Last week, as many of you know, we had an awesome field trip up at Impact to see the campfire, which is a new way of doing visualization. Immersive visualization is very cool. Jim McCusker, who we all know, is now with us on a permanent basis. I described him as our data guru. He's going to talk about a tool that's existed in the lab for some time, for about a year. Linkipedia, he'll get into that. And which some of you have already used in G's lab, others have heard about it. But what we want to have here is Jim's going to give some background and talk through it, but we want this to be an open discussion. We really want to talk about some applications because this area of not just extracting entities from plain text or unstructured documents, but linking into others is very powerful. Linking into even ontologies, which Jim is going to talk a bit about, is incredibly powerful moving forward. And so we want to get those ideas flowing. So without me talking.
Yeah. So anyway, I'm Jim. The inventor of Linkipedia is actually Jin with an N, not the same person. And entity linkers should help you to distinguish between them. So anyway, I'm the director of data operations, basically the data side of John. He's the web operations guy. What is, before we get into this top 10, what is entity linking? This is from Jin's talk. The idea that you have a sentence like, although this New York Jets after released by the Patriots, from 6 receivers on the roster, after cults, etc., etc. And you can have basically mentions on. Oh, this is working. Sorry. If I can make the text there's mention of specific pieces of text, but then we actually have to align that text with specific entities. And in the semantic web, in the RDFS world, we have the ability to take entities of all sorts, assign them URIs as identifiers that are unique and unambiguous. So whenever you use a URI, you're always talking about the same thing as everyone else who talks about the URI. That's actually the underlying magic, if you want to call it that, of the semantic web and of data. Is we know we're talking about the same thing because we're using the same URIs to talk about it. So here we can actually say that Catry actually refers to Jericho Catry, who's a player of the New Jersey, New York Jets. Patriots refers to the New England Patriots, New York Jets refers to the New York Jets, so forth and so on. And these mentions can actually be resolved in a successful way. So Linkipedia itself actually is an entity linking framework. I'm going to take the risk and change the resolution on this just because it's a little bit.
It's better.
Yeah, a little bit better. So the Linkipedia framework provides a framework for indexing ontologies and other RDF, and basically linking the entities that you've indexed against things. We have entity linking servlet, which is just the annotate endpoint. You give it a pile of text, and it will pull out all the mentions. And it'll actually pull out, if it mentions the same person twice, it'll actually have 2 entries for that, which we'll get to in a moment why that's useful, but it is. There's a search servlet, which lets you provide additional context to it, and a checking servlet, so you can actually look at a knowledge base and see what's been put in there. Mostly I focus on this first annotate entity linking servlet. That's where I found most use, and I've actually been building up some capability around it after I inherited the tool. Before we start though, if you want to actually do this yourself, you're going to need to build and install and build Linkipedia. You go to GitHub. So Tetherless World, that's our group. So you should see things in there, but Linkipedia is the endpoint, and you should be able to just go there. Right, and now number 10, we can index piles of ontologies. So we can actually go through and basically you make a directory, you download your ontologies, and then you actually go and run the data process command that will index everything. And this is actually how you go about doing it down here. So actually I built these slides using IPython, so code snippets, you'll see stuff like this next to them sometimes. But basically what I'm doing here is I'm actually using a tool called Wrapper to download the ontology straight from the web, output it in the ntriples format, which is what you actually need for to work with this, and to dump it directly into a file in the ntriple directory. And that I usually gather these up into scripts so that basically all the ontologies that I want, you just download them one per line, and then it will take whatever is in that directory.
The conversion into ntriple is done by you or by the program?
It's done by you. So Linkipedia itself takes as input ntriples. That's it does some text munging to it beforehand that makes it easier. There are tools like Wrapper, RDFlib, and everything else in the world that will output ntriples fairly easily. And a lot of the large databases will do their data dumps as ntriples. So it's fairly easy to work with to begin with. And I see some confusion in the back. Oh, there's a seat up here.
But so just to follow up on that,
yeah.
There's an automatic conversion for taking your ontology and getting it in the form that it will take this in, right?
Yes, using Wrapper.
Yeah,
you can either run it straight from the command line and do it once. You can use you can put that into a shell script to do that a number of times. That's Wrapper is part of the Raptor RDF tools library. We can even index Wikipedia, which actually I did, and I'll show you some example output from that. But basically, Wikipedia has, there's this other project called DBpedia that has been converting Wikipedia into RDF. And for what we're trying to do, actually, a useful thing is the labels dump and the short abstracts dump. This is the RDFS label and the RDFS comment. And the great thing about this is that that's actually the basis for, those two are a good basis for starting your own ontologies from what other people have. So a lot of the abstract entries in DBpedia are actually definitions of the thing that's being talked about, which is very handy. And then you run data process on it, and you go. And that's, it's easy to write, but it'll be a few hours to run because these are big files. Next thing is to actually, oh, I thought this was going to show up. Is to actually extract the entity mentions from from free text, and actually have an example. I ran this somewhere. I can show you the results. But basically, so this is Python. The requests library is actually really handy because this is all it takes to do a service call on requests. You give it some text. You give it a service URL. You set it as the parameters. Actually, if you have a lot of text, there's also, so this does get. You can also do a post to do lots and lots of text. You just use the text as the body and leave off the query parameter. And then the results that come out actually look like, not that. There we go. So so this is the results from doing that entity extraction. Basically, we have this results entry, which has a list of basically. Let's see if I can find where that ends. Okay, so each of these results has a list of annotations and their scores. So the annotation is a particular resource, so there's associated with it. There's a score, and then there's kind of what the text was that was extracted. Now you'll note that obviously called so Lucene has this filter called a what am I blanking on this shingling filter, where basically it'll take the first word, it'll take the first 2 words, first 3 words, the second word and the third word, second word, third word, fourth word. It'll basically progress down the text and provide the n-grams of the text that you give it. We do this to do kind of very brute force entity checking. So we don't say, here's some smart way to extract everything from it, because you'll note we have nonsense and we have nonsense poem, because this says nonsense poem. And so, and it actually hits both of those. It's up to the user to decide how they're going to work with these. But the ultimate result is that you actually get, when you do something like this and run it against Wikipedia, you actually get a fair number of things, some of which are useful, like where's a good thing? Yeah, so there's less things like American Homefront and World War II, but there are more useful things like, well, Jabberwocky. And they'll have different scores, and it's up to you as the user to determine what you're going to do with this. And so you can't just take it all at face value. You have to actually provide some evaluation of it. But so anyway, that's actually does the oh, right. Sorry about that. Oh yeah, so those are scores for the extraction score. They start at 0 and they go up, and the higher they are, the better they are. I don't have specifics about, but it's also weighted by the mix of how Linkipedia does what it does, but there's some how much information it provides compared to the things around it. It also looks at the, and so the one that has the context, including like basically the literals that are around that resource, should look more like the context that you pass it. So I passed it the body of this basically entry about Jabberwocky, and so it should take things that are more pertinent to this than ones that aren't. But there are a number of factors there, and it doesn't always do what you would think is the right thing. So I'll show you an example of something where we're trying to use the underlying semantics of the terms extracted to help them to do something smart with the results we're getting. Okay, so the next thing is that we can actually, based on some text that we get, so if we have use cases or paper abstracts or anything else, we can actually learn our ontology by pulling out a catalog of concepts that we're interested in. And we can start with, things like DVpedia, SNOMED CT if you're into the whole medical thing, MESH, subject headings, which is more a library science thing, or whatever term catalog you have or want. You can grab, if you can get if you can get a hold of Merriam-Webster, you could probably use that too. But the idea is that you want something that broadly covers your domain and then some, and then you use the abstracts that the text that you're building off of to constrain that down to the candidates that you really want to see. So we also set up a triple store with the index resources so we can actually look up the values that we get. Then we extract text from a corpus, using this. And then for every time we get a mention, we actually generate a class like this. So we get basically this is using RDFlib again in Python. This generates a URI in our local namespace, and we're creating a local part by taking the labels and title casing them and stripping the spaces out, and then we build kind of a graphlet, a small piece of ontology graph, and then we add any of the labels that are available. One thing that's interesting about DVpedia is that if you do this against their Sparkle endpoint, you will get all of their labels in every language that they have, which is actually way further along than a lot of ontologies already do, because you're lucky if you get labels in English, let alone German and Chinese and Spanish and Malaysian and everything else. So it's actually it can be a way better starting point than what you normally see. The RDFS comments are also available in there, and so I just pull out all of the RDFS comments. I've been moving towards using SCOS definition as my predicate for definitions. I know that RDFS comment is kind of the standard, like the de facto standard, but this is actually what it's supposed to mean. And so in our latest ontologies, that's what we've been using. You add you make it of type OWL class. That's very important because otherwise it's not a class. And I use something called the conceptual modeling ontology. I wrote that a few years ago. It has a useful predicate in there called has primary concept, which lets you link basically data model style ontologies to ontologies. So if you have something like DVpedia or SNOMED CT, where it's talking about a concept, a thought, and it's an article, then you can refer to it without actually subclassing it or equivalent classing it or whatever. This lets you link out to these more conceptual sources and give them credit without actually having to build them into your semantics. So that's kind of our first. That's a very basic. Let's use the semantics of what we have, or what we're extracting, to build something useful. In this case, a pile of words that we're going to stitch together into. You take this, load it into Protege, you start making your tree, you add your superclasses as you need, and then you start adding your definitions, your formal definitions from there. And one of the great things is you have these starter definitions from your source ontologies, hopefully. Another thing we're doing is, I've been keeping up with the numbers. This is number 6, sorry.
Jim, before you go on, could you just scroll back?
Could you contrast, so on this one in particular, contrast this process, which seems very natural. It's a way of like, let's hoover up something that's existing
Yes.
and kind of map it where it's appropriate, but map it in kind of the right way.
Yep.
Okay. Versus what would be the alternative?
Well, the alternative would be to scan the source material for noun phrases and linking phrases, and then start going through those and figuring out which ones you actually want to put in, making lists of them, putting them into an ontology, going out to resources like DVP to find definitions that are appropriate, and basically build from there. It's going to be a lot slower, and it's not going to scale as well.
So a week versus a day.
Yeah, well, or 4 months versus a day. If they found out.
No, the PI thinks it's going to take a week, and the student actually does it in 4 weeks.
Yeah, exactly. Exactly.
But this is kind of our latest thinking of the way to get the jump start. And the way, actually, I view it as kind of a way to understand like the breadth of what you're looking at. Once
Exactly.
you've got some documents, use cases, whatever, abstracts.
And if you're smart about where you get your abstract, if you're working in, say, abstracts, and if you're smart about about where you're getting the abstracts from, and you have URIs for them, you can actually link the classes to those abstracts and use that as you have to go back over them afterwards, but you can actually use those abstracts as evidence that the classes you're using, that they have good definitions. You can actually compare the definitions that you got from those from your resources and compare them to what's actually happening in the abstract, and vet them and make sure that you're actually talking about the right thing, and throw out the stuff that's not supposed to be there. This is obviously a really basic case. We've done this a few times, at least in prototype, and another useful thing to do is to kind of go do another pass through it and see what like junky stuff you get from the text, and basically make a list of stop concepts, like
Stop concepts.
Stop concepts.
Yeah.
Like stop word.
Like
Right.
stop words, but stop concepts. So if you want to talk about Asia and the 80s band comes up instead, then you know that you want to add that to a stop concept because Linkipedia didn't get the context right.
Is that spelled the same way?
ASIA, yeah.
Asia is not. For some reason I thought there was like.
That was the first one that came to mind.
Who's sort of Asia?
Okay, so anyway, so yes, this is a really, it's both quick and dirty, but also potentially a really useful way to get started with an ontology. This isn't going to build your ontology for you, but it's going to buy your bricks and your mortar, and maybe give you a lesson in how to put them together. So another thing that we're doing with Linkipedia, this is actually the core, the original thing that I was kind of pointed at Linkipedia for, was to take dataset descriptions from a project called TWed. They have over 100,000 datasets, and we're annotating classes onto each column of each dataset, which is pretty cool. But we want to what we do is we have a bunch of ontologies that we've identified as being useful to the domain, kind of like in our previous use case. Then for each column description in each dataset, we call the Annotation Service with a column description, and we index the linked entities that we extract and their superclasses into Solr. And so then when we search those datasets, when users search those datasets, they're not just searching the free text to the term that's in the the description in the column description, but it's also based on the labels and very importantly on the alternate labels for the matches in those concepts. So if I search for water temperature, and it says the column actually says H2O temperature, then that's not going to be a match, but those are alternate labels for each other, and so one would come up with the other. And further, if I just look for a temperature, if I have something matched to water temperature in degrees Celsius, and we have and someone searches for water temperature and they don't care about the unit, because that would be a subclass of water temperature, or water temperature degrees Celsius is a subclass of water temperature, that would also come up because that would hit on that thing. And so actually the initial results have us outperforming the bioportal annotation service on the same ontologies. And so and we're not doing as well as manual annotation, but manual annotation is very expensive. Let's see. So another fun thing that we're doing recently is creating word clouds. Actually, they're not word clouds. This is kind of important. We're creating word clouds that are genuinely useful. So this isn't, I say word cloud here, but it's not a word cloud. It's actually a concept cloud. Each of these is a concept from the ontology in the Gates Foundation against a piece of text that we're not showing. And what we do is we compute the inverse document frequency and the term frequency for each concept. So the inverse document frequency is across a collection of documents, and you take the number of documents, divide it by the number of documents the term is in, take the log of that, that's the IDF. And what that is, that's a specificity measure. So the fewer documents a term is in, the more unique it is to any one document that it turns up in. The term frequency is basically how important a term is to that document. And then the term frequency, inverse document frequency, is actually just the product of those two. We actually add in a frequency of 1 for every concept superclass. So we actually build up the tree further, although we don't render it here, but we'll use it for another step. But the TF-IDF score for each term in a document actually becomes a concept vector for that document, and it's a way of comparing those documents together using a backing ontology, using the terms that are especially interesting to you because you've indexed them in Linkipedia. And so that's basis for number 4, which is to actually compute similarity between documents using cosine distance, which also comes from text mining and document clustering. We compute the concept vector for every document we're interested in, and then we compute the cosine distance. This is basically right. So this is these are the magnitudes of each document, and then this is the product of the two vectors, or of the two values of that particular dimension. And each word or each concept is considered a dimension in that vector. But the neat thing is that it gives us a single score for the comparison of any two documents. We can in RDF we can actually make sparse matrices of data by A versus B and then having a score. And in the project that we're doing this for, we keep the term frequency, the TF-IDF, and the document, the cosine distance as measures put into our knowledge base, and we can build visualizations off of that fairly easily. And kind of the simple case is to actually just retrieve all the nodes that have the smallest distance from the node that you're interested in. And that gives you, we've kind of through qualitative evaluation, it gives you very good results, and we see very important things that are related to the document we're looking at. So this one is a bit more speculative, and actually Jason is working on it. And I did some initial results that were not successful because they pulled out some very ridiculous classes. But you can actually generate formal class descriptions for things like column metadata by using the semantics of the classes that you extract. So if you have, this is an example against an ontology called OBOE. And OBOE is based on their entities that you're measuring. There are characteristics, the things that you're looking at about those entities, and then there's also units of measure for those characteristics. So if, for instance, we pull out water, Celsius, and temperature, because we know that temperature is a subclass of characteristic, we can generate a class also called temperature here that is equivalent to, basically, is a temperature measure. This temperature measure is equivalent to having a characteristic of only temperature. And that's actually something that if someone else makes this, this equivalence assertion will align their data with your ontology for you. Further up, we can, since we have Celsius, and we know that Celsius is a subclass of unit of measure, we can say that this temperature in Celsius, or this column is also a subclass of temperature in Celsius. And so we have something that's a temperature and has unit of Celsius. And then we go a little bit further because we actually pull out an entity, water, and so we can say further that we're equivalent to temperature in Celsius and that it's a measurement for entities that are only of type water. So that gives us basically a formal definition of the full measurement type associated with a column. And we link in all the different classes that are available and actually gives us a concrete class that we can instantiate this as the cells of that spreadsheet. Like I said, sorry.
What is the column description?
Column descriptions are things. So the example I'm using here is so if temperature of water measured in degrees Celsius.
So that means those data are contained by the spreadsheet that has columns.
Yeah. Right, and actually the data that we're working with here, there's actually separate metadata files that provide slightly longer text descriptions of those columns. There's short codes and then there's longer definitions for them.
Oftentimes you have a data dictionary.
Yeah, so you'd run this on the data dictionary to get kind of your initial cut, and actually the column extraction and indexing that I was talking about before for data 1, that's actually what this is for, and they have we actually don't look at the data itself ever. We just look at the data dictionaries.
It's pretty common, like with data warehouses and relational databases, to have a data dictionary document. It's typically a spreadsheet, and the first sheet will be typically the tables to make it up, and then subsequent sheets will be either the variables that are used in each, the columns that are used in each of the tables with their definitions, and oftentimes there'll even be if certain fields have only certain codes that are asserted, that'll also be in that document. So it's from our perspective, a data dictionary is something we can chop all up and just provide a lot of extract a lot of information from.
And so I mean, most of these. So what I was trying to do is, so we've been using entity linking in fairly unusual ways. It's not these are not standard text extraction tasks that you might see in a competition. This is intended to be, we have very specific problems. Is there a way to kind of put ourselves further down the road using some sort of automated process for grabbing this stuff? And it's, to a large degree, helped a lot. But you have to think a little creatively about how you apply these tools. So I'm hoping, Yeah. So actually, there's some issues with it. One thing that one problem that we have is we're having trouble with stemming. So meter should be extracted from meters, but organ shouldn't be extracted from organization, as the classic example. It's really hard to figure out where to put that threshold, and I look to our NLP people to help out with that if they can. The other thing is that this shingling approach is comprehensive, but it is time-consuming. We basically look at every. Actually, no, we don't look at it. We look at up to 5 words right now, which probably there are entities with longer than 5 words, but also it means that we're looking at more than we need to when we're doing these searches. So, it could go faster if we had a more intelligent extraction process. I didn't bother with one for this because I just knew I'd get most of it and would eventually come back. The other limitation is it's got a terrible name. So anyone know what Linkipedia means? Because I'd like to know.
So I think it's a link to Wikipedia.
Yeah, but it's
how to name
okay. I figured it was something like that, but it's I guess because we've been using it in actually I only showed you one example that used Wikipedia. It's really useful for lots of other things as well. And so
original the knowledge base is Wikipedia.
yeah.
So we didn't include all the other ontologies, but later on, we found out we have more than just Wikipedia.
So what's the better name?
Yeah, so we're taking so
We got half a salad
we're looking
back
for
there
how
for
so yeah, how can we improve Linkipedia, including changing the name? So
yeah, we really need a new name.
Yeah.
Because Linkipedia is very narrow for the way we're using it now. So
Linkmaster, Entity-tron.
yeah.
yeah.
So yeah,
So we're
Come up
taking
with a name or
submissions,
we'll shoot this dog.
and we'll come up with a good prize.
yeah, we'll give you a free license. Okay, so
We
yeah.
get free access to the GitHub.
Yeah, exactly.
Because you couldn't use this without DBpedia at all. So
Right.
DBpedia is kind of the catch-all. If you can't connect it to one of the ontologies that you've got, then you go to DBpedia.
Well, it's not even a pedia. That's the thing that's worth. It's a
Right.
tool.
Yeah.
It's not even
Yeah.
it's not even a pedia.
That's true.
Yeah.
Well, I think what Han said.
Yeah,
right
if it was
thing.
only
It was linked to DBpedia, so it was kind of mushed together.
Yeah.
But you're right, it's not a pedia.
So under this web service, if you input the full description of this field, like for example, entity linking with ontology, something like that, a description, and the output will be accurate name of the field description.
Yeah.
It will list a whole bunch of interesting documents.
Oh, yeah, that'd be cool. If you can send
It
me
just
that.
sounds like a German word builder. Das linking the entity and with the resources.
Exactly.
I will send that website.
Yeah.
We'll have a competition.
Right. So I mean, I want to open this up.
Free pizza next Wednesday.
I want to open this up. Did anyone have any ideas about did this inspire anything?
Well, first of all, who's been using?
Yeah.
There's other people in this room who've been using.
Yeah.
Do you know anybody else? Maybe not in this room.
Yeah. This group has some listed on that. Donna is the person who uses it. He actually has an alternative way to work in the same country using different resources. But they have some pretty good grasp on that. Anything else?
The other thing about, so one other thing about this is that we have deployed, as I mentioned, we have it on GitHub now. It is a fully self-contained build process, so you don't need to go looking around for extra zip files to do various tasks. It's just all there. So the data process script is in place. The web interface is available as a WAR file, so you can deploy it to Jetty or Tomcat, and all of the libraries are actually in place through Maven and all that, so it actually just builds correctly.
So what would it take to put it up as a service with the current set of ontologies that you've got in there?
The current, well,
So if I want to just bring some text
yeah,
and link it against the set of ontologies that it already knows about, that you made it.
That it knows about.
Yes.
So I have probably a half a dozen different indexes with different ontologies.
Okay, so
stored
for
in them.
one of them,
Yeah.
just for one index.
Well,
Or maybe a couple of them.
I have it deployed for HBGD already because it's used as part of the KICM index process. So that's just for everyone else to generate. We generate these across, I guess, 1,000 different documents, and we do this by indexing a large document repository. And what I did was I set up a production instance. There's instructions on the GitHub website how to do that too. But basically, all you do is you start up a Jetty service on a machine somewhere. You point it at the index that you've created, and you let it run. It's pretty straightforward.
What I'm thinking is I could cut and paste an abstract into a text box and get back basically noun phrases and links.
So like a table?
Yeah, a table or...
Yeah, it would probably take about a day. It's not, there isn't a web interface to, like, there's an API for it right now, but it's not a human web interface.
So it's a command line thing?
It's this. It's
Yeah, okay.
you put in the URL, or you do a post, and it will give you the JSON back. So better than nothing. For what we've been doing with it so far, it's the most useful thing. So it'd probably just be wrapped in a tiny bit of JavaScript or something.
Right, so suppose I had a corpus of documents that came from, say, a very large bank, describing policies and procedures and how to do something.
Yes.
Where the something requires terminology that's very specific to finance, and in particular may be very specific to that group within the bank. You could, using something like this, do a boatload of entity extraction and create from that something useful that would be a starting point ontology.
Yeah.
And you could say, and by the way, I know about FIBO. I know this.
Yeah, but the problem is we need to do this to seed FIBO from things like market valuation, from various places like Bloomberg,
right. You're going to
or
see
for
the
collateral
holes.
optimization, or there things like that, where there's going to be nothing in DBpedia that comes even close to helping
Well, you
find
need
those terms.
for this to be useful, you need to have something to start with.
Well, we have a little bit to start with.
But I mean, if you have some terms identified already,
Yes.
you can, if you have them as entities set up somewhere, you'll be able to tell them.
So you need something to bang it against.
Exactly.
That's the starting point. So, I mean, there are. One can purchase dictionaries for finance, for example, but they're not going to be in a form that would be already ingested as an ontology anywhere,
Right.
like Wikipedia.
Yeah.
They're going to be, text.
Well, if they're, so are they text in the sense that like you can scrape out the term versus the definition at least?
Possibly.
Okay,
If
that
you
would
know
be
what
the
you're
starting point, is to generate URIs from that, ingest the whole thing, extract what you need, and then use that as the basis for your starting point.
Yeah, so we're talking about paper-thin dictionaries. So, like, you'd either have to scan, or hopefully they're already at least OCR ready.
Yeah.
But we're not not talking about things that are readily available online, for example. But then you would want to take the like policy and procedures documents from some of these organizations and bang them against the regulations and see what happens.
Oh, but the other thing I don't think you mentioned is he's also doing noun phrase extraction for the things that didn't match, right?
Right. Well, I'm just using, I'm using a freemium web service to do that.
Okay.
So it'll let me do, I think, 350 articles a month, and it'll list
Yeah,
out
so we're
this-
using a service like that to
Yeah.
pull stuff out of these policies documents now that give us some weighting as to how good or bad those are, and then I get an Excel spreadsheet.
But so
that has it in
this,
there,
you
so.
could bang it against 5.0 or whatever existing terminology you've got. You use whatever the services that either of you use to say, I've got all these other terms that I don't have a definition for.
Right.
So at least you get some sense of what that is.
We'll have to talk about what that process is.
Yeah, and it is a big process because you still end up with a lot of just because you extracted a noun phrase from that sort of text doesn't mean it's a useful noun phrase.
Right.
And so there's a lot of evaluation that you have to do after the fact.
Right.
Both of the extracted terms and of the noun phrases to see.
I've already done a lot of that manually, looking at what the darned extractors come up with and thinking, okay, to a point, this is all right. But then there's all of the internal jargon that this particular organization uses, and it puts funky words together that don't really go together, and that kind of thing. So.
But I'm wondering if Hung's people have some insights, looking at some people in the back, of if you're doing a noun phrase extraction, when is it useful? You're not? Is that what you said? Who is? Needful? Oh, okay.
Conversations to be had.
Yeah, so, we've got a world-class natural language group in this building.
Yeah.
And a few people from it. Right.
Probably beyond the world too.
Yes.
So, do we have any more questions for Jim?
So I do have several high-level comments and questions. Because for this presentation, you have basically presented a bunch of semantics, but you have the prompt regarding to NLP, which you didn't talk too much about the algorithms getting from the system. And basically, from your slides, you said that you have like stemming problem, and you have underground algorithms to do like word extraction and word analysis stuff. So, one common problem is that if high level new NLP technologies and make everything more accurate and efficient. And the other thing is, I'm thinking that is you are like downloading a bunch of ontologies and doing index locally instead of, is it possible that you can provide this service like if I have an ontology somewhere online, publicly accessible, and you have that ontology, and when I have a bunch of text as a query and into your system, you can query it online with that ontology and do some indexing and get tracked instead of downloading everything and doing everything locally.
Right. Well, you have to download it at some point to compute and index the ontology. You can't. It's doing that all in memory would be, especially if it's a big ontology, wouldn't make sense. But the
So that's kind of what Deb was suggesting.
Yeah, I mean,
She
you
was
can have
kind
like a
of
reasonable
imagining
set.
the world that you were just describing, where you select the ontologies that I want to go against. Magic happens. Laptop. But then, select from some library. These are the set that I want to index. This is what I want to apply it against. Boom.
Yeah, and I mean, so that is perfect. I mean, so right now we don't do filtering based on the source ontology, but that is absolutely something we can add to it, and then that would actually put us pretty close in capability to the NCBO annotator, which lets you select your ontologies that you're extracting from.
Does it automatically annotate to tell you what the
Where it is in the text?
Yeah.
No, not yet.
Okay, because that would be very useful.
Sometimes you spend.
It's not hard to do. I mean,
Yeah, haven't we done that in the past?
yeah,
I think we hacked
it's
around with that early in log D.
Yeah,
Because you want to be able to then take whatever resulting ontology you have and say, where does this occur? And
Right.
immediately point me to the point in the document where it occurs. So I can look and see if this makes sense or not, and either remove it or keep it because it's good.
Yeah, and that is it's not hard. It's just niggly. And it's making sure kind of when you get the result back. Like, you just need to align the kind of, as you put in a piece of text as I'm chewing through the overall stream. You have to keep track of the offset, but the offset is based off of there are layers and layers of changes to the text to normalize it.
We like source word pages where the 10th word is. Anyways.
Yeah, well.
Or you can hide it.
Actually, yeah, you can do a mouse over. It's alt text. You can swap in the alt text.
Because in reality, I do like it. I just don't want to be visually distracted by it.
So, any other questions? Those are good questions. Did you have more?
I did have another one.
Okay.
So, one point just struck me just now. So, is it possible that your system can do some like feedback stuff? For example, you have ontology describe one concept, and then the incoming query has another thing like a term, and your system identifies this term. But this term, actually, the whole text corpus contains something new about this term, which can be leveraged and incorporated back into the ontology base, so that you can have more like evolving things out there.
That would be useful. I don't know if where the loop should be closed on that though, because just because you're indexing an ontology doesn't mean you're responsible for maintaining it. And so if I'm indexing Obo or the whole Obo foundry, I can pass along an email, I guess, if there's any maintainer. Yeah. Oh, yeah, that'd be the default. Yeah.
Yeah.
But basically, I can imagine pulling the maintainer metadata out of the ontology to figure out how to do that. But
If it's there.
If it's there. But yeah, I mean, that would be a useful thing to do, but is more, that presumes more of user interaction than we've been having to work with.
How would you, here's a wild ass question. So we've been talking about kind of an obvious form of entity linking with entities are words, and we're linking to things. But what if they're in other expressions or other, it could be the appearance of mathematical formula and or some articulation and some description of that and or
Would we need to
image representation.
Would we need to reduce the also actually image representation? Also, that's basically image search. So you're saying like resolve entities based on what's in the picture?
Yeah. Well, I'm just trying to. There's different entities. Okay.
Yeah.
I guess if I was to construct a use case, there would be like there might be an image, there might be a word, there might be this. We don't necessarily know that they're connected. It's not the easy case of a cat.
Right.
But the idea, what I'm specifically thinking of, is when you've got some expression of scientific result, for example, and you want to relate that maybe to some other representation.
The mathematical one. That could be pretty interesting, but also fairly intense in terms of normalizing the formula.
Well, yeah, that's right. Yeah, right. Well, I guess the question is one of maybe representation. Is there some?
Yeah.
Might there be some canonical way to represent them? And then that's what you.
Right.
We do some of that in FIBO, and there's also some work that Dermot did a long time ago, and some other people on describing formulas in an ontology, but and then for using rule engines as well. So there's a bunch of different rule systems that you can do. Take OWL and dump it into, say, iLog or something like that, so that you've got a representation. But the challenge there is what you really care about is what concept is represented by this variable in this formula.
Exactly, yeah.
And that's the thing you really want to know, and it's not necessarily clear that that's easy to pull out. I mean,
Right.
that's what I want to know for market valuation. That's what I want to
Yeah.
know for calculating collateral optimization. That's all this. That's the secret sauce for the banking world, and it's hard.
Yeah, and so like, for example, the formula for F equals MA is the same as the formula for TF-IDF equals TF times IDF. And it's just that the labels are changed. And so
Right.
depending on,
How do you know you're talking about the same thing?
Exactly.
So any other questions? Ray, got any more?
But those were good.
Yeah. So if not, let's thank Jim.
And do send suggestions for Linkipedia renaming. We will come up with some prize that's better than free pizza.
And sign up for TWed.